Hello again, this is my video on quantitative data analysis. I'll be going through descriptive statistics as well as inferential statistics, looking at what they are and different calculations that you would need to use without the correct software. A central tendency is a value used to represent a whole set of data by finding a central position. Central tendencies consist of the mean, median and mode. The mean is the average of a set of data, and so will show what result the average person may roughly get from doing something. Therefore, this is the most common measure of central tendency. To work this out, you must add together all of the numbers in a set of data, then divide this number by n, which is the number of results used. For example, if someone done 3 vertical jump tests and got 40, 45 and 45, you would add these together to get 130 and divide this by 3 to get a mean of 43.33. The median is the middle value in a set of data when it's arranged in size order. Therefore, the number will be somewhere in between the highest and the lowest number. To work this out, you would put all the numbers in size order, then you would work out the middle value by crossing off one number at a time from the highest and the lowest values. If there is 2 numbers left at the end, then you would work out the middle value between these 2 numbers. For example, if you are left with the numbers 44 and 46, the median would be 45. Finally, the mode looks at the most common or frequent value within the dataset. Therefore, you would choose the number that comes up most often. For example, in a dataset with the numbers 20, 24, 21, 19, 20, 23 and 20, 20 is the only number to appear more than once, and so this would be the mode. However, not all datasets have recurring numbers, and so this can always be used. Other descriptive statistics are measures of dispersion. There are also 3 of these, and they show how spread a set of data is, and therefore describes the variation in the dataset. One measure of dispersion that is used most often, especially in scientific experiments, is the standard deviation. This number shows the spread of the data from the mean value, and so looks at how much the results may be increased or decreased from the mean. This is shown in a distribution curve, which I covered in the last video. A standard deviation is shown as in the slide, with the mean first plus minus the standard deviation. For example, 10 plus minus 2. This means that the average result is 10, but can vary by 2 at each standard deviation. The range shows the difference between the minimum and the maximum value, and so is calculated by minusing the minimum from the maximum. The problem with this is that outliers are included, and so the range may not depict the true spread of data. For example, if the results 12, 22, 25, 21, 19 and 26, the range would be 14, but most of the values are within a range of 7, and so the outlier makes the data seem more spread. Finally, interquartile range shows the range for the middle 50% of the data. Therefore, you do the same calculation, but you must find the difference between the upper quartile and the lower quartile. This means that outliers are excluded, and so there is a more accurate representation of the spread of data. To find the lower quartile, you count the total numbers. To count the total numbers, add 1 and divide by 4. The upper quartile, you multiply the lower quartile by 3. These answers give you the position of the quartile and not the actual value of the quartile. Standard deviation can be worked out using the equation at the bottom of the screen. To make this equation easier, it is good to make a table like the one on the left, as it gives you all the correct numbers you need. Firstly, the first x in the equation is the score of the participant, and the other x with the line above it is the average score. Therefore, you must do the score minus the average, and then square this number. You would do this for each of the scores, as in front of the brackets there is a sum of sign, which means that you must do this step for all scores and add them together. Once you have added all of these numbers together, you must divide the number by n minus 1, which is the number of scores minus 1. In this case, it is 13. Once you have divided this number, you square root the answer, and then you will have the standard deviation. In order to calculate the interquartile range, you must first find the median, the lower quartile, and the upper quartile. You must know that n equals the number of scores, and the answer you get from these equations gives you the position of the quartile and not the actual score itself. For example, if you got an answer of 2.5 for the lower quartile, this will be shown here as it's not the first answer or the second, and it's in between the second and the third, so that's 2.5. To calculate the median, you must do n plus 1 divided by 2. Therefore, you would do 9 plus 1 divided by 2, which equals 5, which means the median is 72. Then, the lower quartile, so you would do n plus 1 divided by 4, and the upper quartile is the lower quartile times 3. Once you have done this, you minus the lower quartile from the upper quartile to give you the range, the interquartile range. In this example, it is 15. To calculate the dependent t-test, you should firstly make a table with the two sets of data, the difference in the two sets of data and the difference squared. You should also include the sum of all of these numbers, as these will help you to calculate this. You firstly put the sum of the differences on the top of the equation. Then you must calculate n times the sum of differences squared. You must also calculate the sum of the differences and square this number. You take this away from the previous equation. You then divide this answer by n minus 1 and square root the answer of this. Then you divide the sum of the differences by this answer. Once you calculate this, you calculate your degrees of freedom, which is n minus 1, which equals 5 here. And you look down and you find the level of significance for 0.05. You then use the critical value table to find your critical value, and if your t-value is higher than this, then your results are significant, whereas if the t-value is lower than your critical value, then your results are not significant. The independent t-test requires you to make a table with the two sets of results, the means and the standard deviations. Firstly, you get the mean from the first set of data and minus it from the second mean. Then you calculate the first standard deviation squared divided by the number of scores, and do this for the second standard deviation as well. You then add these results together and square root the answer of this. Then you divide the first part of the equation from the second part of the equation to give you the t-value. Then you calculate the degrees of freedom for the critical values table. To do this, you add the number of scores for each set of scores and minus 2. This gives you the degrees of freedom number, or DF number, on the left-hand column. You then find the level of significance 0.05 and find your critical value. If the t-value is larger than the critical value, then there is a significant difference. Whereas if the t-value is smaller than the critical value, there is not a significant difference. To calculate Spearman's rank, it is important to make a table again, including the two sets of results, each rank in size order, lowest equals 1, highest equals 10, or if there's more results, it will be 11, 12, etc. You must also include the difference between the two ranks and these differences squared. To start the calculation, you get the sum of the differences squared and times this by 6. You then calculate the number of scores squared and minus 1. Then times this number by the number of scores. You will divide 6 times the sum of the differences squared by this answer. You then take this answer away from 1, and this gives you your Spearman's rank. Keep this number as you will compare it to the critical values table. To calculate the degrees of freedom, you do n minus 2, and then you use the level of significance 0.05 and find your critical value. If your Spearman's rank value is higher than the critical value, then there is a significant correlation or relationship.